Alrighty.
So your direction as engineer teams to answer this question. When in your life have you completed the same steps that Thomas did as an environmental engineer? He said we ask good questions, they imagine possibilities, they make a plan, create, and improve. Talk with the engineers at your table about a time in your life where you've done what Thomas did around the oil spill, where you ask questions, imagine possibilities, plan, create and test your ideas, and improve. Talk to each other about when you've done that in your life.
In the same tank where we release those fish.
So when is the time in your life that you've done that?
When we released the fish, we had to know how much water we had to give the fish, how are we put them in when we release them and stuff like that.
So what about times where what is something that you've done to improve? Hey, what about some time where you've done ramp building?
Oh yeah.
What about the ball? I forgot you guys have your own thing, so just remind me, when I clap, do what you're supposed to do. I love that. So, I heard things at a few different tables, but I didn't hear over here. Remember, when somebody's talking, Tylee, when somebody's talking, our eyes and ears are on them. If you agree with what they're saying or you've had a similar experience, you can show them. And if you'd like to add on, say, oh, I agree with what Ahmad said, I'd like to add on. Have a seat, please. Also, pencils are to be used appropriately, like every time you use pencils. And you actually don't need one right now, so they can be in the blue bin. Table 5, someone from table 5. When is a time in your life, somebody from the table, where you have asked questions, imagined something, planned, created, and improved it? I'm asking someone from table 5. Ethan, and you should listen, you might have this. When is a time in your life where you had to ask questions, imagine solutions, plan, create, and improve? You've done a lot in this class, but I was thinking about other places. Can you speak up so everybody can hear you? So when you ask questions of an expert. Sir. And by the way, when a classmate is talking in a different part of the room, where should our eyes be? All right, so we're coming in the back to Ian. And you don't need your folders open right now. They should be down and closed. So you're talking about when we release the shad into an oil-free zone. What step was that? Asking, imagining, planning, creating? You made a plan to release them into a place that was oil-free? So there are a number of ways in your life already that you act as engineers. One of them is in think tank a lot. When you build ramps and you're working as teams, you ask me what you need to do. You are oftentimes improving on your designs. Today, you are going to become environmental, thank you, you can go sit back out, environmental engineers. But environmental engineers don't just use information randomly. They use math, Tylee, and science to solve solve the problems. And so today's question is, how can they use their science knowledge of soil and water to solve a problem? And I'm going to stop and wait for my drummers to stop because it's very distracting. And I still see two people drumming. Right. Marco, please put your folder down. So today, as environmental engineers, we need to use our knowledge of soil and water to investigate a problem. And we have a big problem. I received an email from the mayor of a town recently. And that town was up by where Taya was, where she saw this oil spill. And she took all of these pictures. So it was in Washington State. And they've had some experience with oil spills, right? You remember how they cleaned them up with these for the name? It's been 2 weeks. Kevin, please focus. Booms. And they've had a few oil spills, but they've had some other things going on. And I got this letter in the mail recently, and it tells us of a problem. And they've asked us to learn about soil and water and try to solve their problem. I retyped up the letter so that we can read it together, and I want you to think about asking questions, what you might have as questions for the mayor. And he wrote us, "Dear environmental engineers, I am writing to ask your help." By the way, I'm over here, but the words are up there, so take a look. "I am the mayor of Greentown. We're having some problems here in Greentown, and we don't know the cause." That sounds like a mystery. "Some people who live in Greentown have noticed that plants are dying. I noticed it myself with the plants in the town garden. Other residents have noticed sick animals. In the big pond in town, frogs are dying. We have environmental test results from 3 years ago, and all of those seem fine. I've sent your teacher the results along with a map of Greentown for you to review. Everything in town seems to be continuing as normal, and we don't know why the plants and animals are having such a hard time. Please help us figure out what's going on, and we look forward to hearing what you find. Sincerely, Mayor Higgins." Now, before I show you what data he's talking about, that there's a positive and a negative, both. I want you to look at these questions. Let's ask some questions, because he also gave me more information. First of all, what are some of the problems that Greentown is having based on that letter, Finian?
Somehow the environment is going or
Yeah.
getting dirtier.
Somehow the environment is going on a downhill slide or getting dirtier or something. What else, Kevin? Animals are dying. This is critically important, right, Michaela?
Yeah.
Animals are dying. What, do you think that the plants and the frogs are likely to be the only organisms, Allison, that are being affected? Or do you think there might be other things being affected? Why do you think that?
Because a bunch of animals live in the water, and it could be the water.
So you think, you're making a hypothesis based on what you know, so if frogs are dying in the water, there's other animals that live in the water, and therefore it might be the water. That's a prediction. We're going to figure that stuff out. What other living things, Chad, and then I'll come over here, might be in Greentown's ecosystem? Remember, an ecosystem is all the living and non-living things in a community that interact with each other in an environment. So what other living and non-living things might be there?
Fish might be there.
Fish. What else, Miss Amari? Answer the question first. What else? What other things might be there besides frogs and plants and fish? Maybe there's deer in the community. Bennett?
There's probably turtles that live in the frog.
Probably turtles. Probably turtles. Allison and Ian?
Ducks.
Ducks?
No.
Jacob?
What about Miss Ducky Turtle?
It's okay. I'm listening to Jacob. Salmon. Yes, salmon. Probably not in their pond, but perhaps if they have a river running. And last one, Marco, and then we're gonna move on.
It might be like what you call them?
Jellyfish?
Catfish.
Give me a second. Catfish, quite possible. So, here's the thing. You all have great ideas, but now, as environmental engineers, it's not just good enough to have an idea. We need to be able to use our knowledge of science and math to answer them. And this is where I'm going to teach you a little bit about something called pH. So I want you to turn your eyes up here and show me engineer teams. Now, because your class came 10 minutes late today, we are working on a shorter time frame. And I want us to be able to get to our experiment. Everything's set up in that bucket. But we can't do the experiment without knowing what we are testing. So I want your eyes up here for this little poem about two of my chemistry favorites. We're using chemistry today, folks. Acids and bases. You ready? You can read along when you get it. Acids and bases. Now, why should you care? Because acids and bases are everywhere. You put them on salads and they get in the rain. They settle your tummy or clean out the rain. You have to find out what they're all about. If you want to learn chemistry, test it out. Now, the first thing you have to get straight in your head is acids turn litmus paper to red.
Yeah, my favorite color, green.
Inside here are our little chemistry testers you guys will be using today. These are called litmus papers. You will use them. They're individual little teeny litmus papers, and ours are not blue litmus paper, but they turn colors and help us understand if there's acid or, I'll show you how to use it before you do it. We're going to wear our safety goggles too. Acid or other chemicals in the water. So acids react with metals with awesome power.
Oh.
They neutralize bases and taste very sour.
Look at the way. You say the bases are different. You say the
Bases are different from, wait a minute. Bases are different from acids, it's true. Bases turn red litmus paper to blue. They neutralize acids, feel slippery on skin. They taste sort of bitter and are called alkaline. Some people say alkaline, but it didn't rhyme. Well, there's even more to this chemistry tale. Something we call the pH scale. Ooh and off for a minute. I love the pH scale, if only, Marco, because it is beautifully colored, but it is ranked from 1 to 14, and items, hold on this here, items at 7 are called neutral. Based on this chart, tell me what is an example of something neutral?
Milk.
Or?
Water.
Thank you. What is an example of something in the red, yellow, oranges that are acidic?
Lemon juice.
One of the things.
Lemonade.
Thank you. Ready? If you can hear me, clap once. If you can hear me, clap twice. So, I'm going to get to you, Nasir. I can see you're reading the chart very clearly, Michaela and Ian, and this will become critically important because turn to your folders to the pink page. Pink page, quickly. Don't talk to do it. Just do it fast to get to the experiment. Don't talk, just pink. Awesome. I can see everybody's listening good. Listening well. Actually, the listening period. Good. All right. So, and Cooper, if you don't have it, this will go on. If you can hear me, clap once. If you can hear me, clap 2 times. Miss Jones, we have literally 15 minutes, and all I said was open to the pink. Table 4 did it without talking. That's about it. Come on, guys. This is a simple instruction. So take a look at this when we look. Our pH scale numbers from 0 up to 14. Litmus paper helps us test it, if you know what I mean. and water cold?
Neutral.
Excellent. But less than 7, it's an acid. We say greater than 7, it's base. So take a look at your pH scale in front of you. This might give us some important information for our enviro mystery. I noticed that next to, well, what do you notice? Look at this scale and to the boxes next to it. Take a minute to look at the boxes that are next to your pH scale and see what your thoughts are about why you think now the frogs and the plants might be dying. Use the information here. Look at it and talk to each other. Look at it and talk to each other.
Battery acid. Most types of plants.
Talk to your group. Talk to your group. You're allowed to look at it. I've taken
What do you see on that?
I've taken the card twice. Yeah, so you can have the other way. So you can say the fish are okay between like 6 and 8. Okay? All right, I'm looking for engineer teams that are ready. Marco, have a seat. What is something, I'm going to start with Cooper, and Cooper's going to call in the next person, something you notice from this pH scale that you have in front of you.
Fish and plants on this scale shows that most fish and plants are good between 6 and 8 and maybe around 9.
Okay, so based on the information that you saw here, thumbs up if you agree with what Cooper said, thumbs down if you disagree. And I see entire tables with no comment. So Cooper, can you please tell us again what you think based on this so that people can really hear you?
I think that based on this scale, that fish and like plants and stuff really like around 6, 7, 8, and some really tough ones like 9.
And what is something else you figured out from checking out this pH scale and the information on it? Someone from table 3. Someone from table 3, Jacob.
That the problem, if the other fish are dying, it has to be 14 through 10, 10 to 14, or 1 through 25.
So based on the information here, we see that in this range, 10 to 14, fish and frogs die. And we also see in 5 to 2 and 1, fish also die. Which makes a lot of sense because if 10 is laundry detergent, I can't imagine that a fish or a frog would like to be swimming in it. And actually frogs are called indicator species. What are they called?
Indicators.
And that means when they start dying, you know that something's wrong with the pH. So take a look at this. I'm going to move this way so people can see. This is the Greentown data that the mayor sent. And I actually gave it to you guys. If you don't talk, just flip your pink page to the white one. This is the Greentown data he sent. I'm going to show you a map of the town. Hold on, Janice. I'm going to show you a map of the town in a minute, but right now I want us just to focus on this data, this information. Look at the pH numbers. If you can't see them well because they're up here, you may look in front of you. And I want you to talk at your groups. What do you notice about the pH levels 3 years ago, Ian? What do you notice about the pH levels? We have the pond, garden soil, car factory, farm soil, medicine factory, school, all the way down to the neighborhoods. What do you notice about the data 3 years ago? Because they didn't have this problem 3 years ago. Talk to each other.
They are.
Don't even focus on this. What do you think happened? This was 3 years ago. Was there a much talking. You've each had your chance to talk to your tables. 3 years ago, please stop kicking. Talik, you can take a break. Thank you. All right, I'm going to come back to you, Bo. Travis, 3 years ago, we had our data. What are all of those pH numbers close to?
7 and 6. So that was like a good thing.
Yeah, talk to me more. Well, it's not close to 8.0. Why do you think it was a good thing?
Because when you speak and you sit, when it's around a 7 and a 6, that's a good thing.
Thank you.
Because
You're
they
around a
don't
7.
die
Yep.
a lot.
So we already figured out what Cooper figured out from this pH scale is that when you're with fish and frogs, if you're around 6 to 8, you seem to be doing pretty well. And I'm actually going to I need to show you how to test the pH using an acidic pH, a neutral pH, and a basic pH. Before I give you your team's samples. So we have also collected from this town samples from locations around the town. For instance, this is soil. Thank you, engineer team 2, engineer team 5, 3, I mean. Thank you. So, first thing I'm going to do, as you are, is I'm going to put on my safety goggles. All of these liquids, when we're doing experiments and we're working with chemicals, even though I have glasses, I'm still going to put this on. We are testing the pH. Some of this might get on your hands. We are not touching it to our mouths. We're not putting it to our noses. Each group will have paper towel, will have litmus paper that is used to test how much acid or base is in it. And this. My material managers today, I'm going to have to find a new one for table 1, but are going to be Janice, Jasmine, Malcolm, and Amari. As a material manager, when it is time, you will be getting the materials, bringing them to your table, and then when it's time to clean up, you'll be doing the same. So all I should be up here. Marco? All right, Kevin wants to see it, so we're getting started. I'm going to start with the neutral pH. And I'm also going to take out my special pH scale. Remember I said I liked pH scales because they're very colorful? Yeah. So the pH scale, and you'll see when you get to this with your group, is a wide range of colors with a corresponding number. So I take my litmus paper and I try to make sure I only have one. Your group is going to have 2 samples to test. And what do I expect this to change to? Neutral, right?
Yeah.
So, and it's hard to show up, but we want it to be yellow. So first I'm going to put it in. I'm going to take it out. And I'm going to see what color it changes to. This one's... It looks more like the 6, doesn't it?
Yeah.
That's interesting. So that means that our water right now, or at least the water in here, is a little more basic than perfectly neutral. Now let's try the acidic pH. I'm going to carefully open it up. I'm going to take a litmus paper. Now there's 5 or 6 of you per team. Each person may test 1 litmus paper, but there's only 2 samples. So you will need to work together to test them out. And I'm going to put it in. I'm trying to do it here. Let's see. And this one is pretty close to the 1 or 2. So would we want this color to show up in one of our water samples or soil samples? No way, Jose. Otherwise we would say, and we're going to look at a basic sample.
Blue, finally.
Now, just because the water is blue does not mean this will turn blue. Something can be basic, like laundry detergent, without turning blue.
It's yellow.
It looks very, very close to the 10, which is a little bit green. So I'm going to leave these here because you have your job to do. And I'm going to take off my goggles and put them down. All right, so please turn your pages one more because you're going to need to record your results. All right, this is our pH testing result sheet. Each team is going to get 2 samples. When you get your samples, you will put them on the table with the paper towel just like I did. And material manager, please make sure each person has a piece of litmus paper. Unfortunately, ladies and gentlemen, I'm over here. We're running out of time. Mr. Rogers is allowing us to go about 5 minutes late, but if we can't get to it, we at least need to collect this data so that we can work with it and start to understand what might be happening. Your job is going to be to write down the name of the location in town that you're testing, the kind of sample, Roger, that you have, whether it's soil or water, and then test it. Put it next to the pH scale and circle what you found it as. Table 5. I'm not going to give you further instructions, Cooper, so I hope that you get this correct. Then you're going to look up here and determine, did it stay the same or change? Table 5. And I will be choosing one really focused scientist from each team to come and record the pH. When you come in, materials for your team are in the back. Your material manager is going to bring the box over to you. You're going to put your goggles on. You're going to get your litmus paper. You're going to test and record your results. It should only take 3 minutes at the most. Are there any questions about the procedure? Bennett?
So are you going to pick one?
In your bin, there are already 2 sites. So pick one of them, and you can probably divide as a team. Allison, you will be the stand-in for Ahmad. May my material managers please go get your correct bin? Table 5, you are 2 bins. I'm getting more bins. Bring it back, and you may get started as soon. Look inside, and you'll find everything you need.
I got some goggles.
Right there. Table 5 is over. Okay, just put it there. Here, guys, I took yours out. Right. Okay. There you go. All right, guys, get started. Come on, we are Tyleek, you're not allowed.
I'm working with the machine.
All right, so
And I got my
you're going to have to test mango too. Okay? Look what it says. Car factory. So you guys have car factory and you have marshland. So you do car factory and you do marshland. Okay? There should be there. All right, guys, put it in the middle and look. Oh, you guys here. Let's do this. Let's give you. Be careful opening it. You guys can test that one, and they can test down here. So you need more sticks, more litmus paper. Can you say that? I'll get you more litmus paper. Yeah, everyone's goggles should be on. You're working with acids and bases. Ooh, what did that turn? Well, what number goes with it? All right, here we go. Okay, wait a minute. And then you guys have to compare it to your sheet here and write down recorded information. But as long as record Marshland. Do me a favor, Malcolm. Head on up to Marshland and record what you found for your number. Neighborhood A. Hey guys, can you look at that?
And it burns when you touch it.
What do you guys think?
I'm gonna touch me.
Did you figure out? Oh my goodness, look how acidic yours is. And these guys ready? So what is it? All right, so which one are you testing? Greentown Farm. So you need to write that down. Greentown Farm. You can work it. Just say what are you guys finding?
Finding that the
It's
medicine
recording.
is changing.
All right, what do you
Right here.
He's not allowed to touch the materials because last time he was touching all the stuff, he was using all the other stuff, so he was allowed to watch. So we walked out without. Can we fix it? Wow. All right, thank you. Wow, that's crazy. All right, so where's that pH? Exactly what your voices just said, which was stop, look, listen. So, ladies and gentlemen, my direction right now, we are running very late. Thank you, Roger. I need you to put the tops back on your samples. We're going to come back to this. I need Eddie and Jemiah to record on the chart your findings for your 2 locations. I need Michaela and Daniel to record on the chart the findings for your 2 locations. I need Chad and Chelsea to record, Bennett and Travis to record, and Olivia to record. Please go record your pH findings. Everybody else, finish up your paper. Already tested. Okay, well, we're going to pH.
I'm making a song out of it.
And my material manager should start putting everything back in the bin. Back in the bin. Can you clean that up, please?
Why did we put goggles on?
Why do you think you put goggles on?
We're using acid.
Okay, so make aspartame and someone else. You have materials, sir. No. Marco, you already have stuff to clean it up.
Look at that.
You are dropping in your positive pause because you are not actively listening. Okay, I said for material managers to clean up the materials while our people
I'm a scuba diver. I'm a scuba diver.
engineer teams who are ready. Everyone in engineer team 1 was continuing writing. Marco, unacceptable.
Give me Marco.
Show me, I see that.
No, stop.
You may close your folders. You may close your folders. We're going to come back to these.
I'm gonna put them in.
No, not right now. Go sit down, Marco. And next time you may not have the opportunity to use material. I have no
What?
Stop touching her. I'm going to go to the office. I'm going to ask one more time. And I will use what you use. It means nothing if you don't actually do, Angelina, what you just said. So when you say, stop, look, and listen, show me what you're supposed to do, Ian. Marco, sit appropriately. Down. Michaela, sit appropriately. Marco, you can have a seat off to the side. So, before we head across, we are going to regroup. Two things. When you are using, Ian, I'm up here. When you are using materials, it is the material manager's job to clean them up. Please don't withhold things from that person. It is going to be that person's job for the next 2 times we're together. Number 3, you are teams. You're sharing materials. Nobody should have blank sheets where you're recording things. Chad, I'm over here. Sit appropriately, Travis. Before we head across, look here. First of all, I didn't have anybody record anything for neighborhood A and B. What team had neighborhood A and B? Do you know what your PHs were?
Yes.
They were both 8. Thank you, Nasir. On point.
No, we had
Amari.
B.
So take a look here. And who had the pond water? So why is it not written up? So take a look at this data. Put yourselves down. You can't join right now, just at the very end and make that noise, Amon. I'll wait. I'm over here now.
Come on, egg.
Marco, go sit right there, please. Based on the data you see, not just what's in your head, and you can't see it if your head is down, what areas seem to have the biggest change in pH? Angelina. I'd be happy to. Next time, listen, please. Based on the data we have up here, which areas seem to have had the biggest change in pH? Put it down. The pH today compared to the pH 3 years ago.
3 years ago. What the? That was 3 years ago. That was about 3 years ago.
Today.
Stop, look, and listen!
Cooper, it should be silent. Close your eyes and see if you can hear each other. Close your eyes.
That's gonna be on YouTube.
Marco, sit outside. You're coming with me too. And put down my materials. Open your eyes. Your bodies are calm. I'm not sending you across the hall to Mr. Rogers wound up. Look at the data. 3 years ago, the pH looked one way. We tested what the pH is today. What are some areas of concern? Nasir. Garden soil. How much did it change? 1. So is that the biggest change up there, do you think? No. Okay, what about another one, Ethan?
It's not the biggest, but I see a change.
Yep.
On the bicycle factory.
The bicycle factory. Yep, there is a change, but also not the biggest. Where would you say are our 2 biggest concerns? Kevin, what's one of them?
Marshland.
Marshland. What's another one, Bo? I've seen the car factory soil. It looks to me like we might need to go over this a little more. Next time we are together, eyes up here. Next time we are together, we're going to use this data and try to figure out what's happening. Why the car factory soil went from being basically neutral to almost like battery acid or lemon juice. So acidic. We also see the marshland is very acidic. All right, so it's gone down. Please move out of my way. Thank you, sir. We're going to do positive pause. There were many of you on the right path, but for things such as opening folders and taking out pencils, I shouldn't need to remind people how to do those things. My material managers will remain the same next time. You absolutely did a great job questioning and posing problems. Most of you contributed positively to the group and inspired teamwork. Most of you cleaned up quietly. I'm going to set a time limit next time. But material managers, you did well. Teams, you need to listen to your material managers. Active listening, only some of the time. Especially when I'm giving those directions. When we are going to be using lots and lots. You're still not actively listening. You are going to be using lots and lots of materials. It is critical that you use those appropriately and that you listen to instructions. I'd like engineer team 3 to line up, please. Sorry, Mr. Rogers. Looks like we didn't finish it. Engineer team 2. Yes, entirely. I'm going to take him to the office. Okay, thank you. No, not right now. Engineer team 5. Engineer team 4. I'm so sorry. Since you gave me the minutes, I decided to take them. Engineer team 1. Nope, don't ask me about that. Your job is here.
You alright? I'm alright. Dang, you're so big. Bigger now.
That's a tape.
No, it's not big. Did that hurt? Does that hurt?
It's a screen.
Guys, you need to be lined up in space for music. Anybody who's not listening, I'm going to go back and watch the video. It makes it very clear to me who's not going to get to participate in those activities next time. Don't ask. Not right now. I'll be taking
Miss Scott, class, if you have your recorder, step out of line. If you are still in my line, walk across, find your perfect spot, and say stay.
Sorry, I thought you weren't.
Why they got 12?
After I clean up the meeting later, I won't do that again.
We got 12.
Excuse me, you have somewhere to be.
Really, that's a video camera. You wave the video camera like this. That's
Your recorder is in the hallway.
video camera.